All right, so you get an example where the equation is already given to you. So first thing, your first instinct should tell you, okay, I'm going to go type that in. Okay, and then followed by that, you should probably think about what's happening. Okay, what's happening here? So n is the number of people. So whatever is on the left side, that is always my y variable. And t is the number of days since the initial outbreak. Okay, there's a flu outbreak here. So we've got days and people every single time. It's going to be in that order. I also can tell that the number of people that are sick is going to go up, right? Because this is greater than 1, so it's going up. So continuing that, it says the equation only remains valid for the first 60 days. So it's actually putting a limit, like it doesn't keep growing indefinitely. It does say that, right? It doesn't say just graph for the first 60. It does say it's only valid for the first 60 days. So that's important. And that is basically a limitation on your domain and on your range. That is what that is doing there. So I'm going to go ahead and graph this. It's not a very good graph, so I'm going to try again. I'm going to try zoom 6 for standard first, and then I'm going to try zoom fit. Takes a little while usually. There we go. So zoom fit at least lets me see what the start. For now I'm going to leave it like, well, it's for the first 60 days. So let's see my window. I should have my x max set to 70, right? Because that's my number of days is along the x-axis. Y min, I'm going to change that to, I don't change anything else. I just change x max, x min, y max, right? That's it. So I'm going to go -10 there for the min. I'm going to go a little bit higher for that. I have a feeling that I need to probably include a higher limit for the max. So hit graph. There you go. For now, I'm going to leave it like that. So let's see what else is being I'm asked to do. I'm asked to graph. Okay. So it says make a well-labeled graph. The number of with the number of sick people each day for the outbreak. And of course I want to include 60. I want to include 60. I know that the y-intercept is 0, 1, 20 just from that. So I know I need to start there, and this is going up. So watch this. I'm going to use a highlighter to make my point here. I find out when x is equal to 60 what is y, and that's my reference point, 60, 1,000. So when I walked around, I did see this, right? So you have to include, you have to go all the way up to probably 2,000 or something like that. And I find one more point, right? This is a different highlighter here. I find another point somewhere halfway, like in the 30s, somewhere here. That's that one right there, okay? This one here is my end point right there. So I've got 3 points that's going to help me determine that curve. Population, number of people, time is in days. I came all the way up to 80 here. What did I do here? 500, 1,000, 1,500. So every tick is worth 250, right? Every tick is 250. So that's a pretty good graph. That's going to give you everything you need to move forward. So we're going to give you 3 marks for this. So I usually go labels, scale, and shape. And the shape means you have the points where they belong. So that's usually how we mark. And I do have my equation on there as well. So then you get full marks, no question about it. Okay? Okay, keep going. It's asking me how many people will have the flu after 15 days. Days is my x variable, okay? So I go second trace value, that's 1, 15, and I get 234.58. I can't have that because people don't exist partially, right? So all or nothing. So you need to round to a whole number there. How long does it take until 500 people have the flu? 500 people is my my y, so I go second trace intersect. it's 31.94 days. Is it okay to have a decimal? Yes, because days you can break down into hours, minutes, seconds. It's okay to have a decimal there. This one I'm curious to see if you got this one right. What is the doubling time? What is the doubling time? What you have to do is you take your initial population of 120 and you multiply it by 2. Right? So you get, I don't know why there's a 240 here. Sorry, my bad. We want to know how long does it take to go from 120 to 240. So you let y2 equal to 240, and then you find the intersection, and that's 15.51 days is your doubling time. Okay, so that's what you write down there. I would give you 2 marks for this one, because 1 mark is for just realizing that you have to double your initial, and another mark is for getting the intersection. You get 1 mark for 3, you get 1 mark for 2, and 3 marks for the graph. So that's a total of 7. Okay, so a mark out of 7 at the top. 6, 7.